In this video, we're going to walk through a practice problem in physics that involves an elastic collision in one dimension. So let's jump right into this example. It says a 3 kilogram ball moving to the right at 5 meters per second collides with a 2 kilogram ball also moving to the right at 3 meters per second. Find the final velocity of both balls, assuming a perfectly elastic collision. So let's go ahead and sketch this out. We have this 3 kilogram ball. That's a little big. A 3 kilogram ball moving to the right at 5 meters per second. And it will collide with this 2 kilogram ball that's moving to the right at 3 meters per second. So let's say this is the 3 kilogram and this is the 2 kilogram ball. And our question is, when these two balls collide, what will be the final velocity of both balls? Now we're told to assume that this will be a perfectly elastic collision. So what we need to know is that in a perfectly elastic collision, momentum is conserved and kinetic energy is conserved. Now, because the momentum in this system will be conserved, here's what we can write. The initial momentum, so momentum is denoted with a lowercase p, the initial momentum in this system must be equal to the final momentum after the collision. Now, momentum, that's calculated as mass times velocity. So the initial momentum in this system is going to be the mass of the first object times the velocity of the first object plus the mass of the second object, in other words, the second ball, times the velocity of the second ball. So this initial momentum in the system must be equal to the final momentum, which will be the mass of the first ball times the final velocity of the first ball, plus the mass of the second ball multiplied by the final velocity of the second ball. So let's go ahead and fill in all the values that we know in this equation. So here's what we'll get. The mass of the first ball is 3 kilograms times its initial velocity is 5 meters per second, plus the mass of the second ball, that's 2 kilograms, times its initial velocity, which is 3 meters per second, must be equal to the mass of the first ball, so 3, times its final velocity, plus the mass of the second ball, which is 2, times its final velocity. So if we simplify a little bit, on this left-hand side, we get 15 plus 6, which is 21. So we end up with 21 is equal to 3 times the final velocity of the first ball, plus 2 times the final velocity of the second ball. Now, what we'll notice is that in this equation, we have two unknowns. It's the two final velocities. So in order to solve for these two final velocities, there's actually one other equation that we need to know. And that is, in a perfectly elastic collision, what we can say is that the initial velocity of the first ball minus the initial velocity of the second ball, it must be equal to the final velocity of the second ball minus the final velocity of the first ball. So for this equation, let's fill in what we know. The initial velocity of the first ball is 5, minus the initial velocity of the second ball is 3. And that's equal to the second ball's final velocity minus the first ball's final velocity. So 5 minus 3, that's 2. So we can simplify and say 2 is equal to v2 prime minus v1 prime. And now what we have is two equations right here that both have two unknowns. So what we can do is we can solve for one of these variables and then just substitute it into the other equation. So it doesn't matter which equation we choose, but it looks like it will be easier to work with this second equation. So notice what we can do here. To solve for v2 prime, we can just add this v1 prime to this left-hand side. So what we're going to get is v2 prime is going to be equal to 2 plus v1 prime. So now what we can do is we'll take this value for v2 prime and we'll plug it into v2 prime right here in this equation. So I'm going to clear a little bit of space here and we'll do that. Okay, so here are the two equations that we left off on. So we're going to take this value for v2 prime and we're going to plug it in for v2 prime right here. So here's what we get. We end up with 21 is equal to 3 times v1 prime, plus we have 2 times this quantity right here. So we'll say 2 plus v1 prime. So notice that now this equation only involves v1 prime, so we can solve for that value. So if we simplify a little, we get 21 is equal to 3 times v1 prime plus, let's distribute this 2, we get 4 plus 2 times v1 prime. We'll combine the like terms, and let's subtract this 4 to this side. So we get 17 is equal to, on the right-hand side, we end up with 5 times v1 prime. And to solve for v1 prime, we'll divide both sides by 5. So we find that v1 prime is equal to 17 divided by 5, that's 3.4. And we're talking about velocity, so we'll say meters per second. So this is the final velocity of the first ball after the collision. And now to solve for the final velocity of the second ball, we can just take this value and plug it in right here for v1 prime into the second equation that we had. So what we'll find is that v2 prime is equal to 2 plus 3.4. So that turns out to be v2 prime is 2 plus 3.4 is 5.4. And we're talking about velocity, so we'll say meters per second. So this is the final velocity of the second ball after the collision. So that will be our final answer to this question. Those are the two velocities of both balls after the collision. And again, the key to solving this type of problem was using these two equations right here. So by using these two equations and just filling in all of the values that we were given, we were able to solve for the final two velocities.